we will now use the product rule or the product property to simplify radical expressions. So, radical expressions that represent the nth root of nth powers, such as the square root of 25, which is the second root of 5 to the second power, and the cube root of 8, which is the third root of 2 to the third power, can be exactly determined as decimals. Namely, the square root of 25 is just 5, and the cube root of 8 is just 2. So we can get exact decimals for those, 5.0 and 2.0 to be exact. So these can be expressed exactly as decimals. These radical expressions are called rational. So the square root of 25 is rational, it's 5.0. The cube root of 8 is rational, it's 2.0. On the other hand, radical expressions such as the square root of 2 and the cube root of 25 are called surds. Surds, S-U-R-D-S. A root of a positive real quantity is called a surd if its value cannot be exactly determined. Some surds can be factored into the product of a rational number and a smaller surd. So in some cases, we're able to factor these surds into the product of smaller numbers and surds using the product rule, which we have here. This is the product rule. It says if the nth root of A and the nth root of B are both real numbers and n is greater than or equal to 2 is an integer, then the nth root of A multiplied by B is equal to the nth root of A multiplied by the nth root of B, and the other way around too. The nth root of A times the nth root of B is equal to the nth root of AB. As an example, if we were trying to do the square root of 50, now the square root of 50 is not rational, it's a surd, but I might be able to factor it into a smaller surd multiplied by a rational. All I have to do is think of all the rational square roots that I know. Well, the square root of 4 would be the first useful one, which is 2. The square root of, 9 would be 3. The square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. And of course the square root of 100 is 10. So if you only have single digit numbers as the radicand, if the radicand is only a double digit number, then this list would be all the possible rational factors that we can factor out of a surd. So when I'm looking here at the square root of 50, the one that I'm looking for is the factor that goes in on the left hand side here, and the only one I see that goes in is 25. 25 goes into 50. 25 goes into 50 2 times. So we break down 50 into the square root of 25 multiplied by 2. And then because of the product rule, I can split that up into the square root of 25 times the square root of 2. And the square root of 25 is 5, which is the rational part. And the square root of 2 is the smaller surd because it's smaller than the square root of 50. And that is actually the same number. 5 times the square root of 2 is exactly the same as the square root of 50. This list here provides a list of all the rational roots, all the rational square roots up to 100. So those are the kind of factors we're looking for. So let's try question 1 here. Question 1 says, well, it starts off with part 1 of 3, so there's 3 parts here apparently. It says, what is the largest perfect square that is a factor of the radicand? When I'm looking at the radicand here, my radicand is 32, and I'm looking at a perfect square that's a factor of 32. And here are my perfect squares underneath the radicals over here. I'm trying to break the square root of 32 up into the product of one of these numbers and another number. So let me see. 4 goes into 32 evenly, but I'm looking for the biggest rational factor I can get. And 16 actually goes into 32, and 16 is a bigger number than 4. So when I break up the 32, I'm actually going to break up the 32 into the square root of 16 times 2. 16 times 2. Which we can split up even further into two separate radicals, just like we did here, into the square root of 16 times the square root of 2. Square root of 16 times the square root of 2. And the answer at the end is going to be 4 times the square root of 2. So let's see how we're going to answer this question. The first part says, what is the largest perfect square that is a factor of the radicand? Well, I found out that that number, the largest perfect square that's a factor of 32, is 16. So that's the answer I'm going to give here for this first part of the three-part question. The largest perfect square that goes in there is 16. So 16 is the largest number on this list that's a factor of 32. And I submit that part. Then it opens up the second part. It says factor the square root of 32 into radicals with the perfect square from step 1 as one of the radicands. So it wants me to split it up the way I did right here. So whatever we did right here is what we're going to put as the answer for step 2 here. So for step 2, I'm putting in the square root of 16 times the square root of 2. Square root of 16 multiplied by, so I ease over here, multiplied by times and it's going to be times the square root of 2. So square root of 2. Okay, so that's what it should be looking for this part 2 here. I'll submit it. And that was what it was looking for. And then the last says simplify the radical. So that's the final answer, 4 square roots of 2. So now when it's finally asking me to simplify, it's asking me for this. So the final part of this is 4 times the square root of 2. 4 square roots of 2. 4 square roots of 2. And that's the final answer. So we submit. And that would be question 1. Perfect. So for question 2 then, well, question 2, we're switching it up a little bit. For question 2, it turns out we're not looking for perfect squares because question 2, we're not dealing with a square root. For question 2, we're dealing with a cube root. So it's a third root of 192. It's the third root of 192. So the first thing we need to do is we need to answer question 1, or part 1 of this question here, and find out what is the largest perfect cube in this case. Not a perfect square, but a perfect cube. So we want to know what these perfect cubes are. So let's look at a list. Let me see. The cube root of the first one, the smallest one, 8. Well, other than 1, of course, because we know the cube root of 1 is 1. So I'm looking at the cube root of 8. The next one will be the cube root of 27, which is 3. The next one will be the cube root of 64, which is 4. And then the cube root of 125 is 5. And then the cube root of 216 is 6, but 216 is bigger than 192, so I should be able to work with this list. I just need to find a number on this list that is a factor of 192. So basically, I just need to work my way through the list until I find a number on the list that 192 goes evenly into. And it turns out that 192 is evenly divisible by 64. 64. 8 goes in also. 8 goes in also. But when it says find the largest cube of a whole number that is a factor of 192, that number is 64, because 64 goes into 192 3 times. And that's the largest one that goes in. So that's the answer for the first part. The answer for the first part here, what is the largest perfect cube or cube of a whole number that goes into 192? The answer is 64. 64, and I submit that part. Then it asks, write it as a product. So I'm going to break it up into the cube root of 64 times the cube root of 3, because 64 times 3 is 192. So that's the next step, is the cube root. So I hit that, cube root of 64 multiplied by, And then I'll do the cube button again, cube root of 3. So I've broken it down now into 64 times 3, because 64 times 3 is 192. And that's the second part. And then the last part then is to just simplify the cube root of 64. We said the cube root of 64 was 4. So the final answer here is going to be 4, which is the cube root of 64, cube roots of 3. Cube roots of 3. So I've broken it down into one factor that was rational, 4, and a smaller surd, a smaller cube root, in this case the cube root of 3. So this should be it. All right, so that's questions 1 and 2.